we have the sequence, we have the infinite series of 1 dividing by n squared times n plus 3. And we want to use what's called the limit comparison test to show that this infinite series converges. And so to use the limit comparison test, what we do is we call this right here a sub n. So let the sequence of a sub n be 1 over n squared times n plus 3. And then we have to come up with a b sub n. And so that is similar to a sub n. So in this case, we can let b sub n be the sequence without the 3. So just drop the 3 here and then we get n. And then n squared times n is n to the third. And so we let b sub n be 1 over n to the third. And then we have to find the limit of a sub n divided by b sub n. And we have to show that this limit right here is equal to some finite number that's greater than 0, meaning positive. And then we can say that if b sub n converges, then a sub n converges. Or if b sub n diverges, and then a sub n diverges. And so for this particular problem, we want to show that this infinite series right here, this infinite series converges. And therefore, we need to show that b sub n converges, and then we can say that a sub n, the series a sub n converges. And so now that we have formed the sequence a sub n and b sub n, first we need to find the limit of a sub n over b sub n. So in the place of a sub n, we have 1 divided by n squared times n plus 3. And then in the place of b sub n, we have 1 divided by n squared. And so this becomes, and then we can simplify this like this. Dividing by 1 over n to the third is the same as multiplying the reciprocal. And so now we have n to the third dividing by n squared times n plus 3. But this is equal. And then if we n squared times n is n to the third. So we have n squared times n, which is n to the third, and then n squared times 3, which is 3n squared. And then we'll divide the top and everything on the top by n to the third, and everything on the bottom by n to the third. So n to the third dividing by n to the third is 1. And then n to the third dividing by n to the third is 1. And 3n squared dividing by n to the third is 3n squared. And the limit of 1, it is 1. And here we get 1, and then as n approaches infinity, 3 dividing by n approaches 0, and so we get 1. And so we have shown that the limit of a sub n dividing by b sub n is equal to 1, which is greater than 0. And now we need to show that the series b sub n converges. And so one more time, the limit comparison test says that first we have to show that the limit of the ratio a sub n over b sub n is equal to a positive finite number. And if we want to show that the series a sub n converges, then we have to show that the series b sub n converges. And so now we need to show that the series b sub n converges. And then notice that This is a P series with P equal to 3. So it converges. Recall that if we have a P series and if P is greater than 1, then the series converges. And so we have shown two things, that the limit of a sub n divided by b sub n is equal to 1, which is greater than 0. And then we have shown that the series b sub n converges, and therefore by the limit comparison test, the series a sub n, this is a sub n right here, converges also. So to recap, first, if we want to show that this series a sub n converges, then we have to come up with a b sub n sequence that is similar to a sub n. And then we have to show that the limit of a sub n divided by b sub n is equal to a positive number greater than 0. And then next we have to show that the series b sub n converges, and then we can say that the series a sub n converges.